Astrophysics, the mother science. First and greatest. Well, first anyway. If the current trends in funding of astro in the US is any guide, we'll also be the first to be lowered into the lava like the Terminator. Anyway, back to the topic at hand astrophysics, which we decided about 20 years ago makes us sound more serious than calling the field astronomy. What could be better than studying the entire universe? Everything that exists: dark matter, dark energy, maybe, hydrogen, helium, and metals. Astronomers study an incredibly diverse range of phenomena, and each of these subfields has some pros and cons. So today, by popular demand and my desire to never have to serve as department chair, I will give you my very subjective ranking of astronomy subfields. We'll go in alphabetical order. So, starting with AGN, or active galactic nuclei. These scientists study the supermassive black holes that live at the center of all galaxies. AGN are like dragons. Sometimes they are quiet and sleepy, but when they get gas, you need to get out of Dodge. These days, people are more interested in using AGN to understand how they impact galaxy evolution or as backlights to study foreground gas, so it's a little quiet. C tier. Compact objects. When a massive star dies from old age, it can leave behind a remnant like a white dwarf, neutron star, or black hole. These compact objects are frankly bonkers. I'm talking full crazy town. Pulsars are neutron stars with magnetic fields up to 10 orders of magnitude stronger than we can regularly generate in the lab. Anytime you can't figure out what the hell is going on and high energies are involved, the answer is usually pulsars. A lot of this work goes on in Europe, so B tier if you're a European. Cosmic microwave background. This field involves studying the universe's aura from when it was young and hot, and did a lot of recombination off a mirror in the bathroom of Studio 54. The downside is there is only one universe to measure, so the end is in sight for this gravy train. Satellite constellations broadcast right in their important science bands, and the NSF is attempting to kill the next big experiment in its crib, so not a great time for the field. Sadly, they go into F tier. Cosmology. Cosmologists are like the few rare string theorists that know how to jumpstart a car. They work on the big questions, like what is the shape of the universe, but actually have considered the fact that pure imagination might not be quite enough to crack this nut, and sometimes actually try to use the weird stuff that the screwdriver people call data. Joke's on them, though, this Lambda CDM universe is hella weird. Good luck making sense of that. B tier. Exoplanets and planet formation. The world's hottest club is Exoplanets. It has everything: cool instruments, hot people, adaptive optics, biosignatures, the number one ranking from the Decadal Survey for ground and space missions, a long term vision for keeping everyone employed for at least 20 years, since finding Earth like planets is so damn hard, and aliens. Hell yeah! This one goes in S tier. Extragalactic astrophysics. This is basically the study of how galaxies form and evolve. Sounds great, and this is one of the primary science cases of the James Webb Space Telescope. The problem is that it seems like every galaxy is a slow motion train wreck, with a huge amount of its current state related to its past merger history. Before JWST launched, this field was pretty stagnant. But with JWST in its glory days and bringing in cool data, I think we can put this in C tier. B tier if we assign black holes growth in the early universe here instead of in AGN. Gravitational waves. When two black holes love each other very much, they sometimes decide to merge into one big black hole. This simple act shakes space time itself like your upstairs neighbors on a Saturday night. Sounds awesome, right? The physicists who built LIGO thought so, but little did they realize that after the first couple of events showed exactly what Einstein's theory of general relativity suggested, LIGO would become uninteresting to them, just another astronomical observatory. LIGO now serves as basically a dinner bell for the time domain astronomy community, who we will discuss as soon as we can be sure none of them are actually standing behind us. B tier, since the observatory is new enough that there is still some good stuff to mine from it. Heliophysics. That yellow ball in the sky, maybe it's worth understanding before we worry about the other lights in the sky that are at least 10 billion times fainter? Nah. Turns out we basically don't understand a lot of pretty fundamental things about the sun, despite incredible data. But does that worry astronomers about the conclusions they draw from crummy data about things at the edge of the universe? If you are actually considering this might bother astronomers, you probably haven't met many. B tier. Instrumentation. These are the screwdriver guys that build the telescopes and cameras observers use to measure the universe. These absolute scum looked down on by all other astronomers because they have the audacity to build tools for the entire community instead of writing yet another incremental paper, are in fact the best funded, smartest, and calmest of all the subfields because they have a secret. When they get fed up with the bullshit, they can get a really well paid job in industry. A tier. Planetary Science. Turns out, studying the planets in our own solar system isn't actually considered astrophysics. Despite this handicap, this field has a lot of built in advantages. They can actually send spacecraft to the planets they study, and they can do really cool science with fairly cost effective space missions. Hallelujah! From an astronomer's point of view, the downside is that a lot of the science is actually geology in disguise. And we got into this to intellectually soar through the heavens, not lick rocks. A tier. Simulating stuff. What do you do when the math is too hard? You run home crying to your computer cluster, stroke its keys lovingly, and get it to run a simulation. Does this simulation reflect reality? Well, look. See, after tuning the parameters of the simulation, including in patching in subgrid physics, which basically means adding some random function to plaster over your ignorance, it matches the observational data you trained it on perfectly. So it must be right, right? Right? Anyway, since the late and generous St. Jim Simons decided to revitalize this field with a mega cash infusion, this is a pretty good time for a computational astronomer. B tier. Stellar astrophysics. Stars, the final frontier. These are the voyages of the lonely stellar astrophysicist who basically measures stars to figure out how they work. Like magnets, no one actually knows, at least for anything a bit bigger or smaller than the sun. A pretty chill place to spend a career. C tier. Time domain and multi-messenger astrophysics, or T-DAM. Are you the kind of person that always posts first in a comment thread? Do you see yourself as a nerdy Conan the Barbarian who likes to drive your enemies before you and hear the lamentations of their women? Consider TDAM. This field studies rare objects that appear and then quickly disappear, so you need to be part of a big, fast, and organized team to observe them first and get all those sweet, sweet nature papers. The science is interesting, but the competition over rare targets adds to the stress level. If you have or want a nemesis, try this field. C tier. Thanks for watching, and don't forget to like and subscribe.